So for the following problems, this definition is going to prove useful to us. The first few examples I want to do here, all we're going to do is talking about taking radicals here and convert those over to an exponential form. If you look at part A here, we have the square root of 10. The index number on this radical would be a 2 since it's a square root, and the power on the 10 would be a 1, obviously. So if I'm going to rewrite that in exponential form, how that would be rewritten, well, my base number would be 10. For my fractional exponent that I would need to set up here because of this radical, the numerator would be 1, since that's the power on the 10. The denominator would be 2, since that's the index on the radical. So 10 to the 1/2 is the exponential form. In a similar fashion here on part B, here we've got the cube root of x to the 5th. Well, x will be my base then when I set up the exponential form. The fractional exponent will consist of a numerator of 5, since that was the power on the x, and a denominator of 3, since that was the index on the radical. So if that makes sense, as I move my way over to C here, where I have the 4th root of a cubed, kind of running out of room here, so let's bring this down. How I would rewrite that in exponential form: a would be my base, the rational exponent would be 3, since that's the power on a, over 4, since 4 represents the index number on the radical. Okay, on part D, we add a little something to this as far as what's occurring underneath the root here. We've got a 5th root of 2x cubed, so we got the 5th root applied to a product. For starters here, I'm going to take this 5th root, and to only note the 5th root, I'm going to take this whole 2x cubed and raise it to a 1/5 power overall. What that will allow me to see, since I have 2 times x cubed here, that will allow me to see that I've got this 2 I can raise to the 1/5 power, and this x cubed that I can also raise to the 1/5 power. And if I use my power to power rule, I'd multiply the 3 and the 1/5 to get 3/5 back as the power. So 2 to the 1/5 times x to the 3/5, that would be the exponential form there for part D. Now part E differs just a little bit. Here I've got this product 2 times x, but all of it is being cubed under the radical. So what that means, it means I'm going to take this 2x here, all of it, I'm going to raise it to the 3/5 power. Since this power of 3 is applied to the 2x, that'll be my numerator. This 5 right here in the denominator, well, that goes with the index number here. Recognizing that, I've got 2 times x, both raised to the 3/5. Then I can take that 2, raise that to the 3/5 power, take that x, raise that to the 3/5 power as I apply the power to power rule, and I've got my answer in exponential form. All right, we throw part F in here to show a little bit of a difference between the previous two. The previous two, we had some products that were underneath the root. Here we've got a sum. If I've got a sum of a plus b underneath the root, well, all I do is I take a plus b as a quantity. I could understand that this quantity of a plus b is raised to the 1st power there. If I take that whole quantity now and raise it to an exponent, because I have a square root where the index number would be 2, I would be raising this to a power of 1/2 overall. All right, now we got some examples here where we're going to go the other direction. We're going to take our exponential form, we're going to convert over to the radical form. If I've got 2 to the 1/3, well, thinking about how we did things on the previous slide here, now going backwards, we know this denominator represents the index number on the root. So if I set up a radical, I'm going to have a cube root here. 2 will go underneath that root, and the power that gets applied to that 2 will be the numerator value here of 1. So cube root of 2, that's the same thing as 2 to the 1/3 power. On the second one, where I have 2 to the 3/2, in a similar fashion, if I set up the root, this time it's going to be a square root because of this 2 in the denominator. got a 2 underneath this root. The power that's going to be applied on that 2 is going to be this numerator value of 3. So the square root of 2 cubed results, meaning I have the square root of 8. And since we're only writing in radical form here, we'll go ahead and leave it as the square root of 8. We could break that down further, but that's really not our goal here to understand. Our goal is to understand how to convert to radical form. Now, when you have 3 to the negative 1/2 power, because of this negative, we know using our negative exponent rules that some reciprocals are involved. I need to rewrite this as 1 over 3 to the 1/2 power. Now, with the radical form, I can take that 3 to the 1/2 power that's in my denominator. Because the denominator in the fractional exponent here is a 2, I know I've got a square root I'm working with. I know 3 goes underneath that root. And then once again, the power applied to that 3 is just going to be a 1 because that was the numerator in my fractional exponent. So 1 over root 3 would be the result. Again, I could rationalize to get rid of that radical in the denominator, but that really goes against our goal here for today, just trying to write this in radical form. All right, here I've got a quantity of 6x raised to the 1/3 power. So since the entire quantity of 6x is raised to the 1/3 power, I know my 3 here represents the index number on the root I'm trying to create. I'd have a cube root of 6x as that quantity raised to the first power. So I could just say the cube root of 6x, and that would work. Now how this next one differs, here I've got 6 times x to the 1/3. That 1/3 power is only being applied to the x in this case. So since the 1/3 power is only being applied to the x in this case, I would have a cube root of x. And since that's being multiplied to 6 in the first place, the 6 would stay on the outside of the root. So 6 cube root of x would result. And kind of along the same lines here with this last one, it's kind of like the previous problem. Only here we do have a negative exponent. Since that negative exponent is only being applied to this x here and this 3 is multiplied on, what I should do to start, I should take 3, leave that over x to the 1/3 power as I create a positive exponent now. And then like we saw in the previous example, when we're raising something to a 1/3 power, that means we've got a cube root involved. So I have a cube root of x down here in my denominator, 3 would remain on top. All right, so a couple more we've thrown in here where we're trying to convert to radical form and we've got rational exponents. This first one here, a plus 5 is a quantity raised to the 1/2 power. We threw this in here because we want to remember if we've got a sum, you know, this would not be a situation where I can use any power-to-power rules. That only works when I've got products inside the parentheses here or when I have quotients inside the parentheses here. So since I have something added, this 1/2 being applied to that entire quantity means I've got a square root, because of the 2 in the denominator there on that rational exponent. I've got a square root of a plus 5, and then that quantity is technically raised to the power of 1 since that 1 is in the numerator. So square root of a plus 5 is the answer. Finally, on this last one here where we're converting to radical form, you know, same thing. I can't use a power-to-power rule because what I have inside the parentheses here is a sum. It's not a product, it's not a quotient. So instead I would just write the square root of, since everything's being raised to the 1/2 power, the square root of that quantity, u squared plus v squared. And since it's a sum, again, I can't take the square root of u squared, I can't take the square root of v squared. I have to leave this as is. That is simplified. So our last examples here, we're actually going to go through and find some numerical values. I've got 4 problems here that have a lot of similarities to them. If we look at this first one here, where we got 64 to the 2/3 power. Well, let's start like we've been doing here in the previous examples by converting everything over to a radical. If I convert it to a radical here, got a denominator of 3 I'm working with in the rational exponent, that would be the cube root of 64. And then my numerator here in the rational exponent is 2, meaning I could apply it as a power here to that 64, or I could apply it overall like so. Remember, you do have that flexibility with these rules. Now, I'm applying the power overall because I know the cube root of 64 is pretty easy to figure out. I know that's 4. So I've got 4 being squared, making my answer for 64 to the 2/3 equal to 16. So similar practice here on the next one, 64 raised to the 3/2 power. This time, denominator in the rational exponent is a 2, so that means I've got a square root of 64 that I'm taking. Now I've got to decide with this numerator value in the rational exponent of 3, should I raise the 64 to 3, or should I raise the square root of 64 to 3? It doesn't matter. It's just easier in this case to raise the whole thing to a power of 3, since we know the square root of 64 is 8. 8 is being cubed. And then 8 cubed, I actually multiply that out, that comes out to be 512. Okay, so now I've got negative 64 raised to the 2/3 power. So I'll be consistent here. Start with my denominator here on the rational exponent. That gives me the index number on the root I'm trying to create. It'd be the cube root of, it'd be a negative 64. Got to make that decision again. Do I want to take this numerator value of 2, raise that as a power on 64, or raise that as a power overall? Once again, just makes more sense to raise it as a power overall because the cube root of negative 64 we can figure out pretty easily. Cube root of the negative is going to be negative, and cube root of 64 gives me 4 back. So I've got negative 4 here being squared. Negative 4 squared, of course, 16. So, last one. We've got negative 64 raised to the 3/2 power. Okay, maintaining the theme here, you got a denominator of 2 in the rational exponent. That means you've got a square root. A square root of negative 64 that you are taking. As far as the numerator value of 3 is concerned on that rational exponent, I'll raise that as a power overall because, hey, we've done that in the previous 3 examples. It makes sense to continue doing that. Okay, we do have an issue with this one. We have an issue because we're taking the square root of a negative. We do have imaginary values that are a possibility because we've talked about complex numbers before. But as actual values are concerned, as real values are concerned, we're not going to get a real number back here. So since I can't take the square root of the negative, this one simply is going to have no solution to it because no value exists. Actually, I'm going to correct myself there. I'm not going to say no solution because I'm not solving any equation here. I'm going to say simply that this does not exist.